Okay, here are the bell ringer problem answers. So I line these up vertically instead of horizontally so I can do the subtraction more easily. So 9 minus 8 is 1, 6 minus 3 is 3. 69 minus 38 is 31. 2 minus 4, well, you can't do it, so you do have to borrow here. Now, 12 minus 4 is 8, and 7 minus 7 is 0. 82 minus 74 is 8. 177 minus 63, 7 minus 3 is 4. 7 minus 6 is 1. 1 minus nothing here, so 1. 144. 451 minus 268, I do have to borrow again here. 11 minus 8 is 3. 4 minus 6, can't do that one either, so I borrow again. 14 minus 6 is 8. And 3 minus 2 is 1. Now that you've gotten all the answers to the bell ringer problem, you should probably head over and take the quiz right now before you forget. All right, this is lesson 1.2. We're still talking about integers, and it's on page 10. So if you're following along, page 10. And it says adding integers with the same sign. So here we have two positive integers, and here we have two negative integers being added together. So that's what they mean by the same sign. It says add the absolute value of the integers, then use the common sign. So here, 2 plus 5, well, the absolute value of 2 is 2, and the absolute value of 5 is 5. So you add those. You get 7, and you keep the common sign. Well, they were both positive, so my answer is positive. We've been doing that all our lives, so that one's pretty obvious. Over here, this is kind of new, but we look at it. We have -2 and -5. So we look at their absolute values, or look at the number parts, 2 and 5. We add those together and we get 7. But then we have to keep the common sign, a negative. Here's a negative, so we keep the common sign, which is negative. We make it -7. Well, another way to say this is when it's the same sign, add and keep. Add the number parts, keep the sign. Add the number parts, keep the sign. So let's look here. Adding integers with the same sign. Here they're using a number line to do this. So they've got -2. So you start at 0 and they move -2. And we're adding to that a -4. So when we're all done there, we've actually moved -6. When they put a -2 together with a -4, they get a -6. So they check their answer on a number line. Here are some problems for you to do on your own where you're adding the same sign. Okay, here are those on your own problems 1, 2, and 3. Remember, we're adding integers with the same sign. So we add the number parts and we keep the common sign. 7 plus 13 is 20. And they were both positive, so my answer is positive. I have -8 plus -5. So they put this one in parentheses here, so we don't have -8 plus -5, and it would be a little confusing. So they put this in parentheses so you knew it was a negative. So -8 plus +5. -8 plus -5. The 8 and the 5 make 13, so I add the number parts because they're the same sign, and I keep the sign. -8 plus -5 equals -13. Sometimes I like to think about it like if I have a group of 8 negatives and I add 5 more negatives, now I have 13 negatives. Here I have -20 plus -15. Same sign, so I add and keep. Add the number part, keep the sign. Same sign, add and keep. Well, moving on in the lesson, we come to a part here that says two numbers that are the same distance from 0, but on opposite sides of 0, are called opposites. For example, -3 and 3 are opposites. All right, the next key idea here, adding integers with different signs. So now it says subtract the lesser absolute value from the greater absolute value, Then use the sign of the integer with the greater absolute value. And that might seem a little confusing, but we'll do a couple of them and you'll figure it out. So 8 plus negative 10. Notice, different signs. I have a positive and a negative. So what I do now is I subtract the number parts. And 10 minus 8 is 2, so I get a 2 over here. And I keep the sign of whichever number part was bigger, the greater absolute value. So the 10, there are more negatives here, so it wins and it gets to keep its sign. Over here I have negative 13 plus 17, different signs. I have a negative and a positive. So I subtract the numbers. 17 take away 13 is 4. And which one had more? The positives had more, so it gets to keep its sign. Positive 4. So remember, it was same sign, add and keep, and now we have different signs, subtract. Okay? So same sign, add and keep, different sign, subtract. Keep the sign of the bigger number. The additive inverse property states that the sum of an integer and its additive inverse, or opposite, is 0. So 6 plus negative 6, 0. Negative 25 plus 25, 0. And then over here it says algebra because we're not using numbers here, but a plus negative a. We don't know what a is, but I have the number here and its opposite. And whenever I add opposites, I get 0. Okay? So, and it makes sense because, look, they are different signs. So I would subtract them. 6 minus 6 is 0. And I wouldn't keep either sign because they're the same absolute value. I wouldn't keep, aren't more positives. There aren't more negatives. So therefore, 0 is neither negative nor positive. Here are the answers for the on your own 4, 5, and 6. Negative 2 plus 11. Different signs, so I subtract the number parts. 11 take away 2 is 9. And I keep the sign of the larger number. 11 has more positives than the 2 has negatives, so we keep it positive. 9 plus negative 10. Different signs, subtract. 10 take away 9 is 1. And we keep it negative for the 10. Negative 31 plus 31, different signs, so I subtract. 31 take away 31 is 0. Oh, I should have known it was 0 because they're opposites. And anytime you add opposites, you get 0. And I don't put a positive or a negative out here. It's just 0. Okay, for the problems we're going to work out here on page 12, 1 through 39, the odds. Okay, so I like these vocabulary and concept checks because it actually makes you think about what you're doing. Number one, how do you find the additive inverse of an integer? Remember, that's the same as its opposite. So how do you find the opposite of an integer? Change the sign. So, for instance, if it were 3, its additive inverse is negative 3. And if it were negative 7, the additive inverse is 7. Just change the sign. Number 3, it says tell whether the sum is positive, negative, or 0 without adding. Explain your reasoning. Well, for number 3, it would have been positive. Why positive? Because the positive number has a larger absolute value. Positive. The positive integer has a larger absolute value. Skipping to number 5. Negative 10 plus negative 18 is going to be negative, because we are keeping the common sign. Remember, same sign, add and keep, and those are both negatives. So we would keep it negative. Number 7, it says, we'll tell whether the statement is true or false. Explain your reasoning. And for number 7, it says, an integer and its absolute value are always opposites. An integer and its absolute value are always opposites. Well, let's think about that. -3 is an integer, and its absolute value is 3. So those are opposites. But 5 is an integer as well, and its absolute value is 5, not its opposite. No, this is false. Why is it false? Because positive integers are equal to their absolute values. Excellent. For these next 8 odd problems, we have to remember the rules. Same sign, add and keep. Different sign, subtract. Keep the sign of the larger number. So here we go. -4 plus -6 equals, well, 4 plus 6 is 10, and we keep the common sign. Same sign, add and keep. Over here, different sign, subtract the number parts, and keep the sign of the number with the greater absolute value, which in this case is the positive. So I keep it positive. Number 13, 8 plus -8. These are opposites. And whenever I add opposites, I get 0. 15, -3 plus +13. Different signs. So I'm going to subtract the numbers and keep the sign of the 13 here. So keep it positive. -3 plus -1, same sign. So I add the numbers and I don't forget to keep the sign. Number 19, 0 plus -11. Anything plus 0 is just the same number. That's called the additive identity. -13 plus 9, different sign, so I subtract. 13 take away 9 is 4. And the negative has the bigger absolute value, so we keep it negative. And finally, -25 plus -9, same sign, so I add the numbers and I keep the sign. All right. For number 25, we have to fix this problem. They have -10 plus -10 equals 0. And they were probably thinking that these were opposites, but obviously they're not opposites. They're the same. I have 2 negatives. And remember, same sign, add and keep. So it should have been -10 plus -10 equals, add the number parts, keep the sign, -20. For number 26, oh no, don't do that, evens. For number 27, the problem reads, your bank account has a balance of -$12. You deposit $60. What is your new balance? So you started off with a bank account balance of -$12, which is horrible because you owe the bank money. They usually give you fees for that. It starts costing you because you took out more money than you had in the bank. But you ran down there as fast as you could with $60 in your pocket, and you gave it to them, and you said, here, please, put that in my account. So you had -12, but you added 60. And it says, what's your new balance? Well, obviously, your new balance is going to be more than -12, but it's going to be less than 60 because you already owed the bank money. Sometimes kids will do this problem and get like 72, or that doesn't make any sense. So different signs. I have a negative and a positive, so I subtract those numbers. 60 take away 12 is 48. And I keep it positive for the 60, which is good because now I've got money in the bank. I might as well take some money out and go blow it on something, right? Just joking. Save your money. Well, on these problems, there's actually some tricks you can do to make them a little easier on yourself, although you don't have to. Some people would just go from left to right here. -8 plus 13, different sign, so I subtract to get 5, and I keep it positive. And then +5 plus -13 would be different sign, so I subtract to get 8, and I would keep it negative. But remember, because this is all addition, I can add in any order I want to. And I'm going to add 13 plus -13 first, because those are opposites. So the -8 is going to stay. I didn't touch that one yet. Plus, and this 13 plus -13 is 0. -8 plus 0 equals -8. This one here, similarly, I could add the 7 and the -7 first to get 0. Plus this -12 that I haven't done anything with yet. 0 plus -12 is -12. This one doesn't have opposites I can add together, but I'd actually like to put the positives together first. 6 plus 14 is 20, plus -9. Well, now I've got different signs, a positive and a negative, so I subtract. And I keep it positive because 20 has a larger absolute value than -9, so positive 11. All right, finally, the last 3 problems here. And I've got 22 plus -14 plus -35. I'm going to put, since I can add these in any order, I'm going to combine my negatives first. So the 22 just sticks. -14 plus -35. Same sign, so I add and keep. 14 plus 35 will be 49. And don't forget to keep. Keep what? Keep the sign. So same sign here. Add and keep this common sign. Now I have 22 plus -49. Different sign now, so I'm going to subtract. 49 take away 22 is 27. So different sign, subtract, keep the sign of the larger absolute value, which in this case is the negative. -27. Number 37, I'm going to put the 2 positives together first. So 26 plus 14 is 40. And now I have -19 plus 40. Different sign, so I subtract to get 21. And I keep it positive for the 40. And all negatives now. So which ones would I put together first? Actually, I'm going to put this -41 and the -29 first together first. Same sign, so I'm going to add and keep. But I know when that 1 gets together with that 9, it's going to have a 0 in the 1's place, so I like that better. So -41 plus -29 gives me -70. Same sign, add and keep. I still have to add on this -15. Now you could have added them in a different order. You'd still get the same answer. -70 plus -15, same sign. So I add and keep. Awesome job. Now you can go and do journal page 10 and watch the video for it. See ya.